In question 24a, we're given two simultaneous equations and asked to solve them. Normally the first thing you would do here is identify one of the two variables, in this case either x or y, that's got the same coefficient, that is the same number in front of x, and then we will eliminate those. But in this case we don't have that, so you can manipulate either one or both of the equations so that you do have the same amount of, in this case, y. So I've taken the second equation of 3x plus 2y equals 7, and I've multiplied it by 2 to get this equation number 3, which is 6x plus 4y equals 14. Now there are a range of different multiplications you could do, and you may have done a different one, but ultimately you will get the same answer. And because we've got minus 4y and plus 4y, we add the two equations together. So we get 8x. The y terms are eliminated, and then that 8x is equal to 24, which means we can easily work out x to be 3. Now we still need to find y, so you replace or substitute the x value into any one of your equations. I'm going to take equation 2 and say that instead of 3x, that is 3 times 3, which is 9, plus 2y equals 7. That means that 2y is equal to minus 2, and y must equal minus 1. So our answer is x equals 3, y equals minus 1. When we're faced with an equation that's got fractions, in order to solve it, we want to, in essence, remove the fractions. And to do this, we must first find a common denominator. So our common denominator here, or lowest common denominator, is 12. So we're going to multiply each term by 12. And then back to the first fraction, if we're multiplying by 12, but also in essence dividing by 3, that's the same as multiplying by 4. And the second fraction, multiplying by 12 and dividing by 4, is equivalent to multiplying by 3. And 4/3 times 12 gives us 16. Then the next step is to multiply out the brackets. And then we want to collect all of our like terms together. So we have 13x minus 10 equals 16. In essence, we're adding 10 to both sides then. And x will be 2. In this question, we're given certain information. We're given that SQ is 7.5 meters. The height of the wall is 10 meters. And that means the height is from P to R. It is 10 meters. And the support must be at least 3 meters long. We're also given the fact that angle RSQ is 67 degrees. So really this angle is 67 degrees. Because we're dealing with a right angle triangle and an angle is given, it means we're using trigonometry to help us work out the answer. In that case, the first thing I would be doing is identifying or naming each side. So we have our hypotenuse, we have this angle of 67, so opposite it we have got QR, and adjacent is RS. In order to answer the question, we're going to have to calculate QR, or the opposite side, and because we are given the hypotenuse, in this case we should be using the sine rule. And we know that it is sine 67 is equal to our opposite, which we'll call QR, over 7.5. And that means that QR is going to be 7.5 times the sine of 67. And if you calculate that, you get that QR is 6.90 meters. But we're really asked to show that the support will be effective, and that means that PQ must be at least 3 meters. Well, PR is 10 meters, therefore PQ will be 10 meters minus the distance of QR. So that's 10 minus 6.9. So PQ is equal to 3.1. Therefore, the support is effective. Because it's greater than 3 meters.